Hey guys, welcome back to the channel. I am coding Lunar Rescue. In this series, I am going to be coding the whole game from scratch in assembly. And I'm going to do it warts and all. Any mistakes I make, including my mouse misbehaving. Yeah, so I think we just lost. Yeah, we just lost the emulator there. So hang on a second. Right, it's back. So at the moment, I've just generated this. Interestingly, the game has it's a monochrome game, but it has apparently a circuit or something which allows it to print rectangular colors. So it's a kind of software overlay. And I was thinking about this, and I thought, well, for the main game, that's the overlay that we need. The other overlay is just a pure, it's just a red, everything, the whole screen goes red, and I checked, and it's even the score and everything goes red. So I think I've thought of a way that I could recode this. You see, since this bit is being overwritten, I've actually done it here. So instead of drawing to 25 here, I'm going to just draw to 32. And that way, well, we can change the code here, right? So I'll show you what it did before. I'm just testing it, right? So we'll recode that, and this is what it currently does. Yeah, okay, so it draws this column, if you like, 25, and then this column with these different colors for the score. But I figured if I just do it with 32 across, then I can actually do loops. These can actually be, instead of 3 bars, it can just be a single, because the memory would then be consecutive, wouldn't it? So that would be 96, and that would be 96, right? And that would mean the code would be a lot simpler. Obviously, it would color in this area, and this area, but then I can overwrite that. And if I do want a little logo here, then I'll just print it with tiles anyway. So should be okay. I mean, I might run into a bit of a problem when I wipe the screen, but it's going to make the code smaller. So I think that makes a lot of sense, really. And see, here's where we do the overlay here. And we've got here set D to 0. And the data here is set up so we've got 64 plus 2, that's the color, and that's how many rows. So 64 means 1 row because I'm going to rotate it. But if I change this and halve it to 32 and change these ones to 96, then I'm not going to need to do any rotation, because I'll explain just a second. Let me change all of these. What I'll do is I'll use the bits, first three bits for the color, and the other 5 for literally how many. That's 1 to 8. That should be 64. Yeah, and there's 32. So if you look at the color bar, I'll explain what that means. It means 32 bytes of red, which is that 1 row across. 96 bytes of yellow, 96, 6 is yellow, 96, and then 96 of all those other colors, and then here 64 of 4, which is that green section near the bottom, and then 3 and 6, sorry, 5, 3 and 6, that's magenta, or I should say cyan, magenta, yellow, right? And in binary, those are going to be separated out. So first, so it'll be something like this. Right, I'll split the byte into 2. And this one will be 32. And so that would be there, wouldn't it? I think so. Yeah. Yeah, so basically I can say how many bytes as a multiple of 8 here, and then the color can be in those 3 there, like that, making it a lot easier. And I can demonstrate that. It makes it a little bit more flexible, though I don't really need that flexibility. So here, when I'm doing a row, this is the code at the moment, right? And here, it's doing a rotation to get the number of rows. But we're not going to need to do that anymore. And instead, we'll just get those 5 bits there, like that. And that'll be the number of rows. And then this will be the color. And we'll add bright to it. And then what we'll do now, this is going to be a lot easier. We don't need B here. And instead of C, we'll use B here, because that's going to be the counter now. And this one, we'll draw it. And we'll do ink HL instead, because, as we made the mistake last time, that could overlay. Because now we're doing more than one line, that means it could overlap. Before we weren't doing more than one line, now we are. So we definitely need to think about that. Hey Patrick, all right, welcome. Do you know Z80 code at all, or are you just curious? Or I don't know if you came because we were playing Star Trek the other day. Today I'm doing coding a whole game on the Spectrum from scratch on Z80 and recording all of it. So every time I get a whim to do something, I just kind of think, okay, I'll go on Twitch in whatever time and do it, right? So that loop, we don't need a double loop now, right, for that, because all we're going to do now is just read the 2 bits of data that we need from the data here. 32 rows of 2, 96 of 6, and so on, and split the binary, and it will be shorter code, right, which we want. So we don't need to add here, we don't need to decrease, we don't need anything to do with that anymore, because we're not using, in the previous example, if you look at the color bars that we can see, each one of those color bars was a separate loop, but now we don't need to have a loop where we're adding anything, because we're drawing right through the screen memory without any breaks. So actually, if you look at that color bar system, if you look at the top, the red, well, I can demonstrate it actually, because if I don't draw the second part, you'll see what happens, right? So this is the right overlay here. So if I ret here, that'll turn off. I'll cancel the right overlay. Let's see if that works. I rushed that a little bit, but Right, there you go. So that's fine. So I'm just doing full screen color bars now, full width. And so when we draw this one here, for example, it's 90. It's 96. Before I had 3 rows, and each time it was drawing 3 rows of 25. But now, because it's all the data is all consecutive, you can just draw 96 bytes, and it's shorter code. And then I'll just overwrite it with the overlay, and if I want to put something here with some tiles, I can do that as well. So that's a way I can just redraw everything quite quickly. Right, so just restore the color loop, and that is done. Should be. Yeah. Okay, good. In the previous session, if you look down at the bottom right, I've got all these tiles, and I was working on a system for drawing the landscape. And I set it up so that I could get everything into those 768 bytes, which I did manage to do. But I noticed, if you look at all those green ones there, that's what's used to draw the landscape. And there are actually 16. So that means potentially, excuse me, potentially it means I could draw the landscape using only these bytes here, using only these tiles, and there's only 16 of them, which means I can use one nibble, 2 per tile, which immediately gives me a really good compression rate. Now, I'm not drawing lots of different levels or anything, so I'm not planning on necessarily using anything like RLE or run length encoding or anything like that. So what I might be able to do is just come up with a very simple custom compression routine for drawing these tiles. But right now, that's not my main thing. But basically I'm planning ahead, right? So if you look at it now, what I've got there, 1, 2, 3, 4. Let's see. Let me just turn off these attributes. Help me to see what I'm doing. Yeah, and I don't think this is a coincidence. The tiles, there are 8 tiles here. There are 8 tiles here that can be used to draw the landscape. And there are another 8 tiles here, which are exactly the same but flipped. All right, so it gives me an option of representing the tiles as in 4 bits, 3 tiles, 3 bits, 8 tiles, and then the last bit would be orientation, right? It'd be the left or right. Now, the code needed to flip a byte. It's very short. I know I saw one online. It's only about 17 bytes, so 2 characters. So it would save memory, probably. So it's an option. It's an option. Possibly, draw it on one side and then mirror it to the opposite, to the other side, because that's pretty easy thing to do on the Spectrum because of the way the characters are laid out. So yeah, it could work. We can actually take a look at the layout of everything and see what we actually want. Although of course it's not actually directly opposite, is it? It's in. You see what I mean? I'll show you here. Just a second, easier visually. Just a sec. Yeah, right. So what you can see there, this is an AGD, but you've got, effectively, you've got those 1, 2, 3 there, and then you've got those 2, and then you've got those 3. 1, 2, 3, 4, 5, and it is literally those 8 bytes, and then you've got that sort of platform at the bottom. This is copied directly from the arcade, so wouldn't be too tricky. I mean, I'm wondering, do I even need compression for this? We'll see. The first thing I'm going to do. Oh, and actually, looking at that, that's interesting, isn't it? Because that doesn't tie in with the. If we look at the grid, that doesn't quite tie in, does it? In a second. Yeah, so it looks like in game that layout is going to be slightly different. That interesting. Should be the bottom. Okay. Let's take a look at that. That's interesting. I hadn't noticed that before. Right. So it could well be that the well, let me run it because I'm running it in AGD here. I wrote it in AGD before. So up to that point, those colors are correct, right? There's a color there for the credit as well. So we might need to, put a few pokes in and stuff. But let's just see what happens here. Oh, that's the untested one. Just a minute. No flipping use to anyone, that one. What I need. This one's probably all right. Yep. Okay. All right. Well, no, what I can see from that, and that's interesting, is the overlay is the same, right? It's just that the tiles, these tiles here, are drawn in green over the top. Other than that, it's the same. So the question is, should I draw those green tiles in? Would that affect the rest of the game? Is there any other part of the game that doesn't want to be green? Just go back and have a look. Yeah, so that there, that's not green. So that's no good. We wouldn't want that to be mixed colors. Or this. Unless I put the credit, I could put the credit that lives here, and I could put the credit there, right? That probably wouldn't matter. Yeah, I mean, this is a different layout because it's a vertical thing onto a horizontal. So I could put the credit there and just keep that green. That would make it simpler. I'm setting myself a challenge to try and save memory wherever possible, right? With the outside chance of it being made into a 16K game. I think the game has a chance of that. So Yeah, so that does make me think maybe I'll move the credit up. The reason I'm saying that is because ideally what I would like is to not have to change the attributes at all, apart from when you die, when it goes, everything goes red. So there basically be two overlays, right? So then I don't have to write any code for when I'm printing the UDGs, user definable graphics. I won't need to change any colors. So yeah, I could put the credits here. I haven't decided about this logo Lunar Rescue thing, so there's no reason why I could write the word credit there somewhere down here, and underneath it would be the number of credits, and the lives will be somewhere here as well. In the original it's all sort of at the top and the bottom, but that would make sense. Take it off there, then the whole game lines up, and I could put those green colors in there and not have to worry about them anymore. After that, I just forget about attributes pretty much, apart from when you die. Okay, well that'll kind of do for a start. Let's come back to that though, right? So in terms of coding, sometimes what you'll do is you'll just look at the game. In this case, if it's an arcade game, obviously you'd look at that and you just play it and you look at it and you start looking at the layout and start thinking about things ahead of schedule so you don't paint yourself into a corner. Really, that's what that's all about. And yeah, so I reckon I'll do that. I'll probably just poke those green bits in there, do something with it, get them in there. I'm not doing it now. Right now, I'm just going to work on this attract screen. And it should all be possible to do with those user definable graphics. So how do we do that? Should I use run length encoding, or should I just do it raw? I'm thinking about text compression now. I guess. Well, let's start with, let's do a little bit of code for printing this font, and then we'll worry about the rest later. I start playing about with it, but yeah, I probably want something like a kind of print at routine, and the ability to draw some kind of strings instead of you know, for example, that character there, whatever that line is, right? That's about 12 characters or something. So I don't want to use 12 bytes for that, ideally. And the same for this thing here. So, you know, maybe I'll just have a, maybe I'll write a very short routine for printing a certain number of characters. That might be the easiest way, like a string, you know. And then in the instructions for where to draw, you can have print at, and then we can have, you know, print a single character or a string or a sort of yeah, a set of or a pattern, right? Because obviously, look, you've got that there as well, these dots. I'd rather save as much as possible with that, but obviously writing the code, you also use up memory, so that's anyway. Let's get the data out. I still need to move that one across. So, okay. Move that over here. I might just give it a little bit more thought to whether or not I'm absolutely happy with where all these UDGs are. I'm happy with that as a set there. You know, that set of 16 there, that's fine. I mean, I might cut that off, as we said, we'll see about that. But the rest easy to access. I think they probably are. Yeah, I think so. Okay. I'll give that some thought. Okay, let me do that first then. Let me get this data out. Okay, so paintbrush, Stedix paintbrush has an option where you can select and then export as tiles. So I'm going to export it as a binary. First of all, just because there's a function that I added to AGD that allows you to, let's take a look. I don't really want this one. Have I not got? So what I want is like a definitive version of this game that I've been writing that I can just keep falling back on when I want to reference it. But at the same time, I want to put the new font in. Oh, but if I do that, I'll probably disrupt this code. So, all right. Basically, this code, this has an option where if you press F, you can see, you can reference, you know, and that's going to be the easiest way for me to write all the text in. I mean, there's not a lot of it, but it's going to be easier having that reference. So let's see if I have actually got one already. Something here called Lunachars. Oh yeah, there it is. Right, okay, so I have got one of those. The only difference is I've moved these around, so I'm going to load that binary in, the one I just saved, and that should work. Yeah, okay, so that's there now. You see that little spiky thing? So that should help, because now I can just press this to know what I'm writing. Okay, let's write a routine printing characters. I mean, I could just find one, but I might as well write one because I'm going to try and do everything from scratch. And okay, so we don't need color. We're going to need a simple draw char routine. Okay, draw character stored at VE at address HL. So we'll go load 8. Load ADE and load H. Font is going to be byte aligned. Say E. Hello, Primal Scientist, welcome. For drawing font. Right, so that's all good. And ink E, then we're just going to loop it, right? DJ and Z, loop to draw. And return, right? Okay, so obviously we haven't got the address, but that should be fairly straightforward. Particularly as I've got lookup tables set up for reading the Spectrum screen memory. So for now, when I call that loop, well, obviously what I'm going to have to do now is get this data for the font, right? So let's do that. Yes, yeah, yeah, I enjoyed that too. Yeah, so Monday nights, we're just playing Star Trek. Now, I'm coding in Z80 assembly on the ZX Spectrum, which is kind of my bag. It's kind of what I'm known for. I've done about maybe 10 games, and but I thought it'd be interesting to code a game completely from scratch on Twitch, right? So every single bit of the code, people can see, you know, the long, boring process of writing the game. But I guess if you're interested in it, it's kind of cool. And I'll comment on the way as I'm going along, right? So what I'm doing now is I'm just going to export. I've made the font the one that I want to work with. And I'm going to just export it to the clipboard. Paintbrush doesn't just allow you to export it as a binary. You can also export to the clipboard. So, oh, what's happened? Something weird has happened to Paintbrush. Oh, no, I'm okay. Right, so I want hexadecimal, and I want 8x8 font, 8x8 character. You can't see this, guys, I know, but it's a Oh, Patrick, yeah, good. Well, at least it's good that you know it. You know, you could get back into it. It can be fun, you know. It's a good, fairly simple machine, the Spectrum, of course, and learning. I mean, I didn't learn how to do it in the 80s. I learned it about 4 or 5 years ago, and then I got really into it. So I just like the format. It's a good challenge. Anyway, let me just export to clipboard. What do we want? We want block-based output. I guess. Yeah, I guess 8 bytes per line. I mean, it's not, it's a little bit, fills up the screen a bit, but at least it's each character. So I could edit it potentially, I suppose, right? So separated by a comma. And we want, yeah, def B is good, fine. Export to clipboard, right? So now in the source code here, I can go to, say we can go here, got that aligned, and I can just go, I might just call it font, it's a bit, so we'll call it rescue font. It's annoying that it hasn't added the tab. But we'll live with that. We'll do a replace. Notepad. Okay, so do find and replace. And def b and replace it with tab. Okay. There we go. Now I don't want to do all of them. There's only 96, right? So it's not that many. I don't want to press all on this because otherwise I'll end up adding tabs to the to that data there, which is already tabbed, right? Okay, well that's got 3. Never mind, that's all right. Should have really done 3 tabs instead. Perhaps I can fix that with another find and replace. Will that work? Yes, it will. Replace all instances of 4 tabs with 3. Okay, that'll do. So that is our font, right? So every one of those lines represents a single character. And there are 96 of them. So now let's run a quick test. If we want to print the letter A, then I'll try and print the letter A. It would be fairly easy. Of course, the slightly tricky thing is that, for example, the A there, that's the ASCII is 65, right? So obviously you need to go back 256 bytes. Yeah, just reading saying you learn basic. Honestly, in some ways, learning basic is, I mean, it's good, but it probably, I actually think it's perhaps could be one of the reasons why people find assembly so hard, because it's really so different to basic. And if you're so used to basic, you're in that mindset, right? And you have to really kind of sort of unlearn things in a way, as well as learning them. Anyway, I'm just going to try and draw a character, right? So we'll load HL with 16384, and we'll load DE with, what do we want? Rescue font minus 256, right? Because you need to go back 1 row in order to line it up with ASCII. And plus 8 times 8. I think that will work. Explain what I'm doing there. If it doesn't complain, then I'll explain. Let's see if it was happy with that. Yeah, it hasn't caused an error. So if you look, if you put A in here, like that, then it'll interpret it as the ASCII, right, which is 65. And so it should add the correct, and then this would be, I mean, another way to do it would be, of course, I could subtract 32 from here. It could be A minus 32, right? That's another way to do it. Then you wouldn't need to do the minus 256. But that should point us at, if you look here, 8208, right? And if you look at the font, here is the font. And if we look at 8208, it's this one here. And yeah, well look, that's one single pixel. Yeah, looking at the this is the hex, but 1 0, that tells us that it's looks right on there in terms of the binary. Anyway, I hope that makes sense. Essentially, I'm just looking at getting the address. This is just for testing, right? When I actually do the routine, once I know that that's working, then I'll write a proper routine for printing. But we'll try that. That should print. Right, when we run the code, let's see what happens. No, not that thing. This one. There you go. We have the letter A happily sitting in the top corner there, which is what we want, right? Good. So now what I want to do is calculate any position on screen, 0 to 32, 0 to 20, 0 to 31, and to 24. All right, and I've got a lookup table for getting the Y column. So let's see how we would do that. So probably what we want to do is something like let's say we want to print it 5, I don't know, 10 across and 4 down, right? So let's do it like this. Let's put it into HL, 10 across and 4 down like that. That could be our position. And start position, right? Actually, yeah, thinking about it, what I want to do here is, let's see, right, let's do this, just a minute. Right, I'm going to store H here, because what I want to do is print a character, and then go back to the start, and then go across one. So we'll load CH there, and then when we go to here, we'll go to load HC, inc L. Now we're never going to be wrapping, we're never going to be writing over a line. So that means, so for example, if I do this now, right, then it means that at the end of this code, HL will be at the next, ready to draw the next character. Right, so yeah, so that should work. In fact, what would happen there is if I did it again, I think it would actually print the letter B next to it. Let's see if it does. It's obviously not what we need, but it's a start, isn't it? Just to, always good to check every little bit, right? No, broken it. Okay. What did I do wrong there? Well, yeah, of course, it's this, isn't it? Silly. It's printing in the ROM. Right, so there you go. Good. So the reason that's happening is it's printing the character, going to the next line, and then, of course, we just finished printing A, so now it's getting ready to print B. But obviously, that is not, that's not what we would want, because we'd want some text, wouldn't we, right? So let's figure that out. We'll start with this anyway, right? We'll get the we'll figure out a screen address, right? Ultimately, we're going to want a routine that prints a string of text. So let's figure that out. So let's say that is where we want it in terms of X and Y. I mean, I could have it raw, just raw addresses. But then I'd have to remember them all, and it would just be a hassle. So we'll do it this way. Now we need to convert that into a screen address. Should be fairly straightforward. So the way that we would do that is we'll start with Y. So that is L here. That's our Y address, right? Then we're going to multiply it by 8. In fact, it doesn't matter how you do it, but this is another way that you can multiply by 8, just like that, right? Okay, times 8. All right. Because I've got a lookup table for the address for the Y columns, right? So then we'll go to here and load the Y lookup. Is it H and then L? Y lookup H. Which one's first? I don't remember. Y lookup L. So we'll start with look up the low bytes. Okay. And then we will do here load. Think about this. That low byte is there. What about if I just do something slightly different? Load L with 4. The reason I'm doing this is because I might want to use HL, the HL register down here. It's going to make a lot more sense to do that here, because then I've already got L and I don't. No, because I've multiplied it, so no, that's no good. I'll go back. Load EA, right? Yeah, okay. Then we will load a EE. That's our low byte. Inc. D. And yeah, okay. I'm going to put it in DE instead, and we'll come out with HL at the end. That makes more sense. Yeah, just going to be easier. Load out A. Load A. Because at HL we can load other registers. With VE we can only load A. So yeah, so we'll inc H here, and then we don't need that anymore. We will load H, HL, and we'll load L, A. Now HL has left column 0, correct row. And then D is our X value, right? So we can add a D. Yeah, okay. So in fact, we add a D, because D is our X. So we'll go across 10. And yeah, slow byte here. And then we'll do that, and that should give us HL now has correct screen address. If I'm right, we'll see. Right, okay, so we'll run that. And it should be 10 across, 4 down. Right? Fingers crossed. Okay, that's assembled, no errors. Ten across, 4 down. 1, 2, 3, 4. Yeah, 10 across. That doesn't look like 10, does it? That looks more than 10. Huh, it's in hex, isn't it? So it's 16 across. Dope, but it works. Good. Right, so that's easy. That's a piece of cake, really, isn't it? That's no problem. So now we can print that letter anywhere we want on the screen, right? Easily enough. That will get us our char address. Now that could be handy. Right. Call get char screen address. Char screen address. Yeah, okay. We'll put that as a routine. And we'll say X in B, Y in E. X column, B, Y, row, E, printing text. Good. Right then. I think I'm probably gonna be a bit lazy and use IX. So let's put the data in here. Let's say hello world, and what we'll do is we'll use a nice standard thing that we might do here, where we will say that, and we'll use bit 7 to indicate that that's the end of the text. It saves as a byte as well. Okay. Okay, so we'll go to, yeah, we're not going to use draw char anymore. We're going to be doing something slightly different. So with that, get the character screen address. For now, we're going to just go load IX text data. We'll use IX for now. It's a bit lazy, but never mind. Okay. So we're not going to need that. That's going to get a bit complicated soon. But anyway. Let's call this text loop for now. Okay. Now, let me just remember. Load AIX. And I'm just thinking now. If it's the last character. Yeah, okay, so we'll ignore, we'll test it at the end, right? So what we do is we go load AIX and then we AND it like that. So that just takes that bit off, the one that could mean that it's the end. Okay, so now we've got the correct character. And we want to then multiply that by 8. So we'll do that same thing again. The reason we do that is because each character is 8 bytes, right? Now, HL is already our screen address, so we don't want to be using HL, but we can use DE. Slightly annoying. It's always nice to be able to use HL, isn't it? Well, let's do that then. Yeah, but we'll put that, of course, outside the loop. Okay, so the calculation is done to get it in HL. It's just easier that way. But then now I want it in DE. So I'll swap it out, leave it in DE. Now HL is free to be used. And what do I want to do? Well, basically, load, put that outside the loop. Load B with 0 here, and load here C with A. We're going to load HL with, what are you loading it with? Rescue font minus 256. And then add HL BC. Get address for this character. Okay. And then XDEHL, swap them back. Now HL has screen and DE has char address, right? All good. So at that point, we should be able to then call draw char and then inc ix load AIX, and if we rotate it, well, we could do a check on the bit, I suppose, but since we're reloading it here, then I guess we can just rotate it to the left into the carry, and then if there's no carry, hang on a second. What am I doing here? There. I don't want to increase it yet. Right, so get what we just drew, rotate it 1, and if we get a carry, text is done. Done here, and then here, entire text loop. Probably going to crash. I don't know. Maybe. That should be all right. Looks okay. Let's see. May have got that wrong. I think we've printed all the characters in them. Of course, I need to go across one, don't I? Once I've... no, but the draw chart does that, right? Puzzle. Okay. Time to dig out the debugger, which unfortunately you guys can't see. Go to... (808B). Thing is, I kind of feel like for the benefit of this stream, I really ought to show the debugger. It's just, it causes screen corruption when I do, or it has in the past. Let's see if I can. Right, there is the debugger. I'll put it over there for now. And hopefully it'll behave itself. Okay, so I'm going to set the debugger here at our routine 808B. I really do have to have this debugger if I'm going to show people what I'm doing. So, right, so let's run through it and see where we're going wrong. Right, so we froze it. Yeah, can you see the debugger now? It's not. Do you see that screen corruption? It's annoying, but anyway, it does actually seem to be all right. So we might be okay. In fact, I might even just see if I can do this. I don't know if I can, but if I can, it'd be kind of neat, wouldn't it? Let's have a look. No. I thought I could also show you the registers, but I can't. So, too bad. Anyway, let's have a look at what's going on. So we are loading the address. Let's just see if we've got... Yeah, you see how it just, the debugger just went blank. You have to keep doing this. This is going to drive me mad, that is. Right, DE is the same, and we should have HL at 409. Yeah, that sounds right. That sounds like it's in the right place. 80E5, that's the... Right, and we swap those over. 4090, now we can use here and we get the first letter. First letter is 48, that looks like right. And FF, well that's wrong. It's immediately wrong. It shouldn't be and FF. Right? Fix that. I've obviously put too many numbers here. Yeah, it should be that. Should be and 127. Seven F, yeah. Okay, well we can hard code that in rather than recompile. Hard coded in. Okay, I'm not sure if it would affect it. I mean, it would affect it. It wouldn't, it wouldn't. It would affect it detecting at the end, basically. But anyway. And so that's fine. So now we... oh, right. Of course. Schoolboy error. Again, from me. This is more than 256. Isn't it? Like, if I've got a character like 65, or especially say 9, yeah, say it's like 90 or something, then it's going to go over 256, isn't it? So we actually have to use an 8-bit, 16-bit addition, which is annoying, but not impossible. Okay, so go back and recode that. Right, so what we need to do here is load L with IX, load H with 0. Okay, and then that gives us, oh, okay, so no, there we go. So I'm going to put load L after we've performed the function, right? So now we can multiply it by 8 by doing this. Okay. And we load BC with the location of the font, so then we don't need this load B0 here. Okay. And that means that we're going to add 16-bit, bam, 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 and then we'll, so what we're doing now, we're multiply first, and then we add the offset after, like that. All right, good night. Yeah, all good. I'm not going to be on too much longer myself. We'll finish this a little bit up and then go. Okay, so add HLBC here. And then that's the address. Yeah, I don't think that's, I still don't think that's going to work, to be honest, but oh, yeah, that's okay. Just checking I've done the and thing as well. Okay. It's a start. At least we've got the letter H now. That's a good start, isn't it? Now, could it be that? Get what we just drew and do that. GRC. See, I thought that would work. Let's debug. Okay. Yeah, that's all good now. So we don't need to debug at that point. We want to go to here. And then, yeah, you see this bloody screen correction, very annoying. So that should come up 48 again, looking at the letter H. Yeah, and then we rotate it. And it doesn't set the carry. Yeah, so it should increase IX, which is right. And then it goes back to 8OB1. And that's okay, and then it should get the next letter, which is correct. What's the problem? The problem is, what are we doing? Yeah, okay. The problem is, I can see it. The X here needs to be in the loop. Otherwise, we're not gonna, we're gonna be using the wrong. See, so it's swapping it, it's flipping X and D, and it's done it once, it's gone back, and it hasn't flipped it back, so yeah, it obviously needs to be in the loop. So that it does it every time, I think. Otherwise, the char routine, which increases the character when it prints it, won't, will increase what was DE instead. Okay, hello worldy with an E at the end. Oh, okay, getting closer. Hello oldie worldy, right? Ha. Why is it doing that? Better ask the debugger, haven't we? Okay, so I'm going to look at each letter. Yeah, we might as well check it from here. So that was, let's see. Oh, that's going to be annoying though. Checking it like that every time, having to scroll the mouse to make it show. Yeah, this is why I didn't have it before. Does it help if I move it off the screen here? Oh, maybe it does. Yeah, I think that might help. It's not on the same screen now as the emulator. So it might work. So RLCA, so that's 45. No, it hasn't helped. It's still, it's actually worse. You can see what's going on. It's like, it's just a big mess. I can't follow that at all. Damn it. Because I really want you guys to see this thing. But it's bloody hard to follow. So 4F, that's O. 2O, that's the space, then W-O-R-L-D, and this is C4, right? So that should give us a carry, which it does. Oh. And then I'm calling A to B7 again. Oh, have I got a little rogue routine in there? Is that all it is? It is as well. Look, I've just got that routine calling a character from before. Just, you know, hanging over, so to speak. That's it. That works, I think. Okay. Turn off the debugger. Run it again. I need to remove that trace. What I might do is I might try and use a different emulator if it does that. But there we go. Right, good. Okay, so let's finish up by just printing some text that we actually want. Okay. Let's print this, right? Okay. So that is that's 2. Looks like 2 by 2 actually, doesn't it? All right. So we'll write P3 Luna rescue ZX space 1 2. The last one is 3. Title data. Okay. And we'll put that in here. So X and Y, 2 and 2. Test that. And obviously the other thing we want to do then is drat and double drat. What's gone wrong there? Flipping it. That was working. That was working absolutely fine. It's printing in the right place, isn't it? Yeah. Ah, drat and double drat. What's wrong with that? Oh, hang on a minute. I've got an error, haven't I? I haven't. This is what happens when you code in the middle of the night. It's not text data, is it? I changed it to title data. What a doofus. Yeah. You can see, I mean, I didn't even look for the error. But you see there, errors 1. It says there, make sure you can see it there. It says errors 1. On label not found text data. And of course, yeah, always make sure that whatever you do, when you change anything, just keep an eye on that, because it can happen. Oh, thank God I don't have to debug all of that again. Right, anyway. There we go. Right, that's good, isn't it? That's absolutely fine. That's where it belongs. And we can, of course, make it look a little bit more as it should, because I've got this pattern here. This pattern there on the clear loop, right? So I'm just doing that so I can see the color bars. But if I run it without that, then it looks like this. Ta-da! Good. And let's also XORA out 254A. That just turns the border black. We need a black border. It looks naff without it, doesn't it? Yeah, good. And then, you know, if we want to put the score over there, that's going to be quite easy to do as well. But what I'll probably do now is have a little list of, you know, we'll fiddle about with this next time, but we'll have a list of different fonts, different items of text with the, you know, 4 bytes, like the text address and the columns, right? So that we can, column and row, then we've got a whole list of text and we can just print it everywhere that we want in all the different locations for printing the attract screen. One of the things that's just struck me though is that this effect here could be problematic. We'll have to think about it next time. That is to say, this effect here, please insert coin, right? The way that that works is it's actually currently it's using an attribute. It prints it and it's black, and then it's already printed, but it's on black, right? And then it just prints the colors to do that. So, you know, should I do that, or should I actually make it print letters one by one on a loop? Maybe I will. We'll have to see. I mean, using the attributes is probably easier. But then again, you know, I could also, it's got the same thing there, isn't it, on a timer? So we'll see. But let's print the score. Let's print the score up there as well. Just, and then we'll call it a night, I think. Okay. Score. Okay. And now printing the score will probably have its own routine. But for now, we'll do it. We'll add it, but it will have its own routine at some point. Right, so let's see. Make that into its own routine. Like that. Load IX title data, call text. Right, see if that works. No reason it shouldn't, apart from the fact that I might have made a silly error. That's fine. Okay, so that means we can do the same thing again here. Now, obviously, we're not going to do this. We're going to put everything into a loop so that it loads the data stream. But we'll put it, load DEX will be, oof, I don't know what it's going to be actually. It's like 27, isn't it? Yeah. Right. So yeah, what we'll do is we'll get some kind of loop going on here so it reads the data, and then I'll compile everything that I want to print at once, and then just print it. And then I'll decide later on if I want to use a routine for blanking out, which I might do actually. I might just blank out those little bits so that we can do a simple effect. Maybe I'll print it. I don't know. I haven't decided. I guess I could print it because it's only printed once. It's not like it's flashing or anything. We'll see. Does that work? Yay! We're getting somewhere, aren't we? Okay. Well, that's good. Let's leave it there. Finish up with that. And I'll say goodbye. Take care. Take it easy. Never stop learning. And as always, happy coding. See ya.